That's a good point.
So it'll be very interesting, Frank. I've seen many of your Impact Quantum podcasts, and you guys dive really deep into the subject matter, and that's fantastic to see. More and more people need to understand a little bit what's behind the curtain, just like when we started working in neural nets, machine learning, and artificial intelligence, just to be able to understand the bias or the damage that garbage in, garbage out can do. We don't necessarily need to see the transistors in our laptop to understand how it works or how to actually use it. Same thing will apply to quantum computers, but at the same time, if the accuracy level is not there, let's say you get 99.999% accuracy on your technology. Well, again, on trillions of transactions or pieces of data, that last nine can represent a real error for you as an organization. So if they're looking at it from a shall we purchase this sort of technology, really, really key to think about those nines and where it applies to your business.
So I'm how should enterprises start building their internal quantum literacy without over investing too early?
Yeah, I'm with you. It's so important that there's a champion within the organization who sees the potential or the risk, as we talked about, that actually has a voice at the table. And so it's very difficult building it from the ground up. Saying quantum technology is important for our organization. Well, what's quantum? I don't know how many elevator conversations I've had with C-suite people that within 30 seconds, I had to be able to describe what quantum computing was. And so which is a very difficult task to do for most people.
Well, that's actually what I was going. That's another question that I'm going to follow up with. Like, how do you describe what quantum computing is to the layperson?
Yeah, so whenever I'm talking to a C-suite person or a CTO, my first question is, what are some of your biggest technology problems? And so they would lay out those problems, and I say, well, which ones are the most difficult? That'll be very, very challenging to ever solve. And so they give me those, and I say, what if I had a solution that might be able to address those?
Mm-hmm.
And now we've got a conversation.
Yes.
So
that's a good way to put it.
Without saying entanglement or superconducting or superposition or any of those sorts of key factors in quantum computing. So that's where I'm able to grab their attention, that would put it on the table. And so they need to be able to go back to their organizations and say, when we think about the future, we think about the hardest problems we have to solve. What if we could if we could actually address those problems either in real time or in short order, where we cannot do it today, no matter how great our supercomputers are.
Okay. That's the way in.
No, I mean, and that's fair, right?